So class, now let us learn about derivatives of functions in parametric forms. Now, to learn about that, let us first learn the notation we have used earlier. So on the screen you have the notation dy by dx, which in mathematics we read it as derivative of y with respect to x. And this notation tells us many things. Number one, it tells that there is a graph and the axes are y-axis and x-axis. Number two, it tells us that the variable y changes only when the variable x changes and the graph is smooth. And now on the screen and in the first line, you have seen you have there dy by dx, which you already know. Now dy by dt, dx by dt, they also mean the same thing, the same idea. And one more thing you should note down here is that dy by dt on the left and dx by dt on the right, it means that the variable x and y, they changes exactly at that time when t changes. So t here is therefore called as the third variable, and they call it the parameter. And sometimes in the place of t you can have any variable. You can have theta or any other variable. And now you know that the first equation, that is the first line, existed by applying the chain rule. So after you have applied the chain rule, then you can have in the second line derivative of y with respect to x is equal to derivative of y with respect to t upon derivative of x with respect to t. So in general, this can be simply written as shown in the last line, which you can learn on your own. But most of the time, we'll be using equation number 2. That is the notation used in line number 2. So now let us see some problems, how to use this formula. So on the screen, you have a problem given to you. So on the screen, you can see that x and y, they are variables, and x and y, they changes only when theta changes, and they changes at the same time because they both depends on theta. So how do you find out the derivative of y with respect to x then? First, we differentiate x with respect to theta because we know that x changes only when theta changes. And we differentiate y with respect to theta because we know that y changes only when theta changes. Then to find out the derivative of y with respect to x, we simply divide dy by d theta upon dx by d theta, and that is simply minus cot theta. So this is how we solve problems when they are given in parametric forms.